Try again. There we go. All right, so conditional probability. This is the probability one event happens given that another event happens. So when you see that line there, you see it says B line A, that's the probability that B happens given that A already happened. Okay. Sometimes you don't need to use the formula. Sometimes it's obvious, like this one says, what is the probability that they will both be blue given that the first sock was blue? So it says in this case, we already know what the first sock is, so we just need to know the second sock. And on the tree diagram, it says that there's a 2/7 chance that the second sock is blue. And so that's just it, it's just 2/7. We already knew that the first sock was blue. But sometimes we're gonna need to go back and use this formula. And the formula is the probability that they both happen divided by the probability that that given thing happened. Okay, so I think this is the harder question. What is the probability they will both be blue given that the second sock is blue? And this is a harder question because we don't know if the first sock was red or blue. We don't know, so we have to kind of work with our formula this time. All right, so here is the notation for it. The probability that they're both blue given that the second sock is blue. It's like Dr. Seuss sometimes. So here's the probability that they're both blue, and then this is the probability that the second one is blue. On the next slide, what we're going to do is we're going to put some numbers on that. Okay, so normally when we have an and in here, we would have to be multiplying some probabilities, but the unique thing about this one is that the probability that they're both blue includes the probability that the second one is blue. You see that? So what we're really just trying to find out is the probability that they're both blue. So for the numerator, it's 3/8 times 2/7. We're just following the tree diagram. Give me 1 second. Okay. And then for the denominator, we want the probability that the second one is blue. And so there's two options here. It might be blue-blue or it might be red-blue. And that's why we added these two together. So we've got 5/7 times 3/7, that's the red-blue. And we've got 3/8 times 2/7, that's the blue-blue. So this is our numerator here. And this is our denominator here. And so if I have 6/56 divided by 21/56, those over 56's cancel, and I get 6/21. It's this. That does simplify though, doesn't it? What do we get when we simplify it? Two over 7, good. All right, so the first example is not my favorite example because of the way that numerator is kind of confusing. But we have a couple more examples to look at. You'll notice that the tree diagrams are the same tree diagrams from last class, but we're asking different questions this time. All right, what is the probability that they bought regular gas given that they paid with a credit card? So there's 3 ways that you could pay with a credit card. It could be regular credit card, mid-grade credit card, or premium credit card. This is the formula, the probability that they bought regular given that they paid with a credit card is the probability of regular and credit divided by the probability of credit. So regular and credit is right here. You're going to multiply those two together. Right? Regular and credit. And then we have to find the probability that they used a credit card, and that has 3 parts. The regular credit part, the mid-grade credit part, and the premium credit part. And that's going to be down here. Okay, so regular credit is this. The 8/8 times 2/8. And then the mid-grade credit is this one, 0.02 times 0.34. And then the premium credit is 0.1 times 0.42. And that all adds up to 0.295. So there is a 29.5% chance that somebody paid with a credit card. All right, then we have to divide them. So the probability of R and C divided by the probability of C. And we actually get 83.5% chance. All right, so this is our rapid test example. There's the answer to this is a little bit outside of the ordinary, and so I'm feeling like something in here might be a little bit off because it wasn't what I was expecting, but it's still a reasonable answer. So let's go through it. It's estimated that 3% of the population is infected with COVID-19. That's here. And that means 97% is not infected. Of those infected, 70% will get a true positive result and 30% get a false negative. Of those not infected, 1% get a false positive and 99% get a false negative. So it says create a tree diagram and determine the probability that a person who tests positive actually has COVID. All right, so here's our formula. The probability that you're infected, given that you test positive, is the probability they both happen divided by the probability of a positive result. Same formula. Okay, the probability that they both happen, here's infected times positive. Okay, infected times positive, and that should be in the numerator. There you go. The denominator is your probability of positive. So that would be infected positive plus not infected positive. Okay, so now we have 0.021 divided by 0.0307, and that gives us 0.684. That's actually a very, that's not as much as you would normally get for a rapid test. Normally rapid test positives are usually positive. Like a high percentage of those are positive. It's the negatives that can be false negatives. Okay, but we were able to assess the situation using conditional probability, which is very useful because this is really the question you want answered. You don't really want answered like, what's the probability I get a positive result? You want to know, if I get a positive result, does that mean that I'm infected? Okay. So we have this one here, and then I think we're going to do the, I realized there was one more than I forgot. I think a chit is like a ticket. Is that your understanding? I didn't write this question. So I'm going to say ticket because it's an odd word for me to say there. So bag A has 3 blue tickets and 7 red tickets, and bag B has 6 red tickets and 4 blue tickets. This is a really weird question. Like if you've been like, oh, this is easy, like focus on this question for a second. It says you grab a ticket at random from bag A and you put it in bag B. And then you grab a ticket from bag B. So what I want to do is I want to make a tree diagram for that because it's so confusing. I'm going to duplicate that and I'm going to get rid of this here. Okay, so the first thing we do is we choose either a red or a blue from bag A. Yeah, and they're this white color again. That's so weird to me. Where's my pink color for that? Do you guys see the color for that one? I don't want it to be white. Any help? The line color? Oh, yeah. That's the one. Thank you. All right. So you either have red or blue, right? So we're going to label these red and blue. You should be doing this on your paper, too, because this is really a kind of crazy question. Red. All these people who are absent, they're going to be like, what did you even do on that question? But you guys will know. So it can be red or blue. And the first one's pretty easy with the odds. The odds of red are 7 out of 10, and the odds of blue are 3 out of 10. So we're going to put those in there. 7 out of 10 and 3 out of 10. Okay, but now we're gonna take the one that we took out and we're gonna put it into bag B, and that changes the composition of bag B. Oops, sorry. All right, so let's draw some arrows for the second round. good. Okay, and the second round could also be red or blue. So we're going to do red or blue. But remember, it's a different bag. And remember that we changed that different bag too. So I want you guys to think about this because maybe somebody will be able to offer the answer before I say it. If I take a red ticket out of the first bag, how many red tickets, and I put it into the second bag, into bag B, how many red tickets would there be in bag B? Logan. Who agrees with 7? Who thinks it's a different number? You think it's 7? It is 7, yeah. So bag B started with 6 red tickets, but if I took a red one out of the first bag and I put it into the second bag, then there will be 7 out of how many tickets altogether? 11, good. All right, so if I took a red one first and I put it into the second bag, then I got 7 out of 11 that are red. And that means how many out of 11 are blue? 4, good. That's the tricky part. All right, so in the second scenario, I actually took a blue one out of the bag A and I put a blue one into bag B. And so now bag B has how many blue? Bag B used to have 4 blue, now it has, say again? 5, yeah. So now it has 5 blue out of 11, right? So down here I'm going to do 5 out of 11 for the blue. So how many out of 11 are red? How many? 6, yeah, because you need to have 11 tickets altogether. Okay. All right, that was the hard part, was making the tree diagram, and now we're going to use that to answer the question. We haven't seen the question yet, have we? I'll put that back in just a second. So, what was the question? Oh, what's the probability that the ticket from bag B is red? And they gave us an answer here, but let's see if we can come up with that answer. I'm going back here. So I want to find the probability that the second ticket is red. Okay. All right, so it could be red, red, or it could be blue, red. So go ahead and find those probabilities and add them up. And then we'll see if we get the same. All right, so I'm getting 7 over 10 times 7 over 11 for red, red. Does that make sense? And then I'm going to add to it 3 over 10 times 6 over 11. Let me know if I'm looking at the wrong numbers. I think that's right. You look at it? Okay. All right, so red, red, and blue, red, and then I just need to simplify. So I have 49 out of 110 plus 18 out of 110 equals 67 out of 110. All right, questions? I promised you that this slide is available in Schoology, so if you're having trouble seeing it, you can open that up. Go ahead, Hanif. Yeah, sure. Yeah, I think that was the hardest part. All right. So you take one ticket out of bag A and you put it in bag B. And then you take a ticket out of bag B. So if I take a red ticket out of bag A, there is a 7/10 chance of that, right? I take that red one out and I put it into bag B. And so now bag B has a 7th red ticket out of 11 altogether. So that's this one here. And I know that there's 11 tickets, so I just figured that 4 of them are blue. And they are. It says it right here. In the second situation, I took a blue one out, and so I had a 3/10 chance of getting blue. And I add that blue one to bag B, so now bag B has 5 blue tickets. And that's the 5 out of 11. Is that okay? Okay. All right, let's see what the next question's asking. The probability that the ticket is blue given that the ticket from A was red. And I think this is one of those ones, so it's going to be, all right, we need probability that bag, oh, let me go back and look. B is blue given that A is red. Okay, so I'm going to use a little b for bag B. B is blue given that A is red. All right, this is one where you don't need the formula because if I know that A is red here, then I can see the probability that B is blue. It's right here. So you don't need the formula. You can do the formula and it will work and you will get the same answer, but you should get 4 out of 11 for that one. Yep, and that's what they got. All right, and then the last one says the probability that A was blue given that B was red. And this one we do need the formula. So A is blue given that B is red. A is blue given that B is red. Okay. So I know that B is red, but I don't know what A is, so I'm going to have to do the whole thing here. So I'm going to do the probability that they both happen. A, blue, intersect. That's over here under insert, special characters, and you can just do intersect. This one. Intersect B is red. Divided by the probability the second thing happens. B is red. Okay, so take a minute and do that. Probability that they both happen, so you're going to do blue then red. Multiply those. And then the probability that B is red, there's 2 ways that could happen. And so you'll find those and add them up. Okay? Take a minute and do that. All right, the probability that we get B and then R, so blue and then red, that would be 3/10 times 6/11. So far, so good? Okay, so that was blue and then R. And then the probability that you get R, there's 2 ways you could do it. You could have this one. That's one of the ways. Or you could have red, so that would be 7/10 times 7/11. Okay, so on the numerator, we have just this one way. In the denominator, we have 2 ways. I do believe Desmos will do some of this math for us. Actually, they'll probably do it all for us. Let's try it. Yeah, it does not like something in there. I don't know what it is. Oh, I think it's just the way the fractions are written. It doesn't like that. All right, so I'm doing plus 7/10 times 7/11. Oops. Why is it doing that to me? Okay. So I'm getting this 9/55 divided by 67/110. You guys seem to be on a different topic. Do you want to finish this on your own or you want to keep listening? Okay, go ahead and do it. All right, so I have 9 over 55 divided by 67 over 110. And I'm going to make it a fraction, so I get 18 over 67. Now, all of that was already written on here. I just didn't do the work yet. 9 over 55 over 67 over 110 gives us 18 over 67. Okay. And that was what the last question was asking. So I know that that's a lot to process. I did record this, so I'll post that in Schoology, and you'll be able to look at that later. And we do have an assignment. You're a little bit behind the other class, so you may consider doing like 10 or 15 minutes of this at home. We'll have some time next class, but it might not be enough time to finish it, okay? So this is due on Thursday evening.